Hello and welcome to this new video in the R Analytics course. In this video, we will look at conducting a test of two proportions from binomial distribution using the z-test. The theory behind this test has already been discussed in a previous video on hypothesis testing. We must remember that the size of the samples should be large enough to conduct this test. We have two sets of samples here. One set of observations belong to people who are in jobs, and the other set is of businessmen. Both the groups have 1000 observations each. Therefore, n is equal to 1000 in both. We have 810 people with insurance policies in group A, which is the group of people with jobs. The group of businessmen have 750 policy holders. Now the hypothesis we want to test is whether the proportion of policy holders in both these populations is the same or not. We refer to the proportion of policy holders in group A as PA and that in group B as PB. The null hypothesis we define is that PA is equal to PB. The alternative hypothesis comes from the statement made earlier. We want to know if both are equal or not. Thus, H1 is PA is not equal to PB. Had we said we want to test if the proportion of policy holders in group A is lesser than group B or not, then the alternate hypothesis would have been PA is less than PB. And the other one would have been a right-tailed one, where PA is greater than PB would be the alternative hypothesis, meaning proportion in group A is more than that in B. For now, we stick to the two-tailed test. As per the samples, we have PA is 810 upon 1000, which is 0.81, and PB is 750 divided by 1000, which is 0.75. Now remember, these are just estimates based on the samples we have. The test statistic we had seen in our previous video was this: PA minus PB upon square root of P into 1 minus P upon NA plus P into 1 minus P upon NB. P stands for the pool proportion of both the groups, which is calculated as 810 plus 750 divided by 2000, which is 0.78. Thus, 1 minus P is 0.22. We can use PA and PB in the denominator too. Since these are approximations and we have large sample sets, both the versions are fine. Now when we put the respective values in the Z statistic, we get the value of 3.23875. We can see here in the Excel file that we have individual proportions as well as the group proportion. If we recall what we saw in our earlier video, if the calculated value of the test statistic is less than the tabular value, then we do not reject H0. Over here, the calculated value is 3.239. The tabular value at 5% level of significance in a two-tailed test would be 1.96. Thus, the calculated value is greater than the tabular value, hence, we conclude that the null hypothesis is rejected, which means that the proportions of the two groups are not equal to one another. Let us now see this in R. We will check this through the p-value approach here. We type question mark followed by prop.test. As we press enter, we see on the bottom right, we have a description of this test in R. We can see that it has various arguments that one has to fill in order to conduct this test in R. By default, R conducts a two-tailed test in this at 95% confidence interval. Now we write prop.test. X is the value on which the test has to be conducted, which in our case is the number of policyholders. There are two values for it, 810 and 750 for both the groups. Next argument is the sample size for both the sets, which are 1000 each in this example. So we write n is equal to combination of 1000, 1000. Then we write alternative is equal to two-sided. Even if we do not write this, R will by default conduct a two-tailed test. The moment we press enter, we get the result of our two proportions test. Let us look at the elements of the output. First thing is x squared, which actually is the chi-squared statistic. We will look at this in detail in a subsequent video. The degree of freedom for the chi-squared test is as expected 2 minus 1, which is 1. Then we have the p-value, which is of interest to us over here. The p-value is 0.1449%. Since the p-value is less than 2.5% here, we can safely conclude that we reject the null hypothesis. We also have the confidence interval in front of us, which is 0.02279 to 0.09721. We can see that the interval does not contain the value 0, which again tells us that the two proportions are not equal to one another. Lastly, we have the sample proportions for both the groups as 0.81 and 0.75 as we had seen earlier. Thus, we can safely conclude that the null hypothesis is rejected in this case. This is it for this video. Thank you.